Welcome to 2020 question A1. This is a diametric projection question. So the image below shows a paperweight. It consists of a cube, a square prism, which intersect each other. So let's see our cube and our square prism. The drawing shows the incomplete diametric projection of the paperweight. A pictorial view is also shown, so we can see all that here. Complete the diametric projection of the paperweight. So I'm going to start off with the base here. So just checking, is there any useful angles there? There isn't, so I'm going to have to use sliding set squares here. So set up my set square on the z-axis. Project these down just to get the base prism first of all, and then set up on the x-axis. Okay, so alright, so just projecting various points. This is straightforward enough to get the base. Okay, we can see the edge running back there and back there. We'll fill that in at the end. So next up, we're going to deal with surface by surface here for my cube. So we've got surface G, F, B, C, and H. Those points on this surface. So I'm going to project them back on the x-axis and match them up with the corresponding points there. So set up my sliding set squares on the x. Some of these points have already been brought. So C has been brought down, H has not, so bring H back, G, and F. Okay, so X on the Z-axis then. So find my H coming over, so that's H, G, and G coming back, and F coming back. So H, G, and F. So I can draw in those now. So C goes to H, to G, to F, and back to B. Alright, and lastly then we point E. So sliding set squares again. Okay, so that's E. We do not need to show hidden detail lines in an axonometric view or diametric view or any 3D pictorial. Okay, only show hidden detail lines in orthographic views, as seen here in my elevation. Okay, so that is 3D view completed. Determine and indicate in degrees the true angle between surface A, B, C and the horizontal plane. So surface ABC is this surface here, and here it is again, and here is an edge view of that surface. So we need to say, where can we see our horizontal plane as an edge view as well? So we can see it here in the elevation. This surface down here, the whole thing, all the way along the z-axis and x-axis, that is actually the horizontal plane. Okay, and here is, I'll just use actually a colour to indicate all of this. So here's our edge view of our horizontal plane. Here is the horizontal plane down here. Okay, and we've got another edge view of my horizontal plane. Okay, so as you can see over here in my end elevation, I've got edge view of that plane ABCD and an edge view of my horizontal plane. So if I extend ABCD down here, okay, and that is going to give me the angle that I'm looking for. And they're asking us to indicate in degrees what that angle is. So I actually need to extend some of these lines. Okay, so I got this at 55 degrees. So 55 degrees. Okay, so that's that completed. So that was a nice little question there, linking some of our kind of knowledge or deeper knowledge between planes and edge views of planes in our axonometric type of question.